It has been a little while since my last tutorial. Lots of things have happened, all sorts of new technologies, but I still got a couple of requests for finishing out what I started, which was how to model the Erwin Hauer screens parametrically. And so what I'd like to do today is to pick up a little bit where we left off, but also start in a slightly different way. So what we're going to do is we're going to work with this where we're going to have at least 3 different parameters based on our edge condition that will allow us to control the thickness that we see here. It'll allow us to control how far the aperture is from the edge of the panel, and then we'll also be able to control this depth. And so we're going to do this using 2 patch surfaces in the same way that the Erwin Hauer screens work, in that one half is here, the other half is there. These won't work, at least for my purpose, it won't work just to simply mirror or rotate these, because I want to develop a way of modeling this where the panel isn't square and isn't symmetrical. And so let's start by with a new file. So I'm going to create a new file with large object inches, and I'll start a new grasshopper file as well. Drop in binoculars, which makes it easier for everyone to see what I'm doing. And the way that I want to start modeling is with a plane. And so within Rhino, let's make just a simple corner-to-corner plane. What's nice about this is that if we turn on our points using F10, we can modify this so that it's non-orthogonal. We can also, if we look in the perspective view, we can also see that we can begin to move these points out of being planar. And so what we've got is a slightly distorted B-rep, and so now we've got this. Let's take a look at this and begin to work with it to work in the same way that we did before, subdividing this panel and working with the tangency curves, with eventually adding some thickness and working through this. So let's work through this and give this a try. So let's start with a B-rep, and we'll grab that object. I think I'm gonna, in Rhino, hide that, but now we have the B-rep in Grasshopper, and we're going to use this as our starting point. I'm going to get B-rep edges now. Let's see, B-rep edges. And this is going to give us 4, or actually it's going to give us 1 curve. Let's see. I'll add a panel. Okay, so we've got 4 edges that are there. So we can see those get highlighted, and we've got that. So let's explode these, because this, let's see, maybe we don't have to explode it. Let's see. Let's create a list item. Let's see what we get. I'm going to add 4 outputs from the list item. Let's see if we get individual curves. If not, we'll have to explode it. Okay, we do. So let's just like being able to copy those. And now it's much easier to click on this object or click on these to find which edge we're working with. So now we can see the way that that works. I'm even going to hide using Control Q, hide the B-rep. So we're just working with the edges right now. Now that we've got that, let's subdivide, or basically find some dimensions from this object, from these edges, that will allow us to set up the geometry for what we're going to try and do. So let's start with an evaluate curve, and we're going to do we're going to do some that are diagonal, and we're going to do some that are orthogonal. So let's start with evaluate curve. We're going to have a whole bunch of these over the course of what we're doing. And we're actually going to have 8 of these. I can do them in 2 blocks of 4. And our parameter, you know what I should have done, is reparameterize these before I copy them. And why don't we let's add a slider, 0.02 is less than 0.50. We'll add that to the parameter. Now as we copy this, that's already set. And so let's plug in these curves. And so with these curves, what we've got is an edge. And let's subtract. And if anyone did the previous tutorial, we're going to subtract from 1 using our first slider here. And so why don't we make this the middle width? And so that piece that either comes over or the piece that comes under, let's start to work on that. So we'll name this slider middle width. And the other thing that I tend to do is pull the sliders that I use all the way over to the edge, to the left, so I kind of know where they are. And we can add these curves here, and by subtracting 1, from the parameter, it's going to be 1 minus whatever that parameter is. So when we add this to the parameter, now what we have are a set of elements that move like that. And maybe I don't want this to get to 0.5. So I'm going to change the upper limit to maybe 0.40. Now as I move this from min to max, it can be narrow or thick. And so we'll use these set of lines now, or these points, to create a series of diagonal lines. And so these lines will move across in this direction and across in this direction. So just a little tedious now in terms of working through creating the lines. So let's do a line with endpoints. And same thing, I think we're going to need 4 of these. And we can even begin to organize some of this. Let's say group this, and I can't remember if this name works or not, but let's call these diagonals. So the title was hidden a little bit behind there, but let's start. And so what I want to do is find a place to start. I'm going to look maybe left to right across here and try and find that first point. Of course, it's the last point. We'll start with that. And so we start there, and then we're going to look for the point in the upper right, which is here. So we have that first diagonal. Now we'll find the next one. It's a little faster with the process of elimination. Move in the other direction. Okay. We can group these together. And so we have those diagonals. What we'll see is that those diagonals are not actually falling on the surface that's there because they're straight lines. So if we preview this, we can get a sense for that as we orbit around. That's okay for now. What I would like to do next is to, let's see. Well, let's keep working on these. So now that we have these lines, let's find the midpoint. And so we can again evaluate a curve. I like evaluate curve because it gives us some other options. There is midpoint, but it's nice to be able to have that variability. I'm going to, in this case, it is the midpoint. So I'm just going to use a panel and set that to be 0.5. If we ever want to come back and change that, we could introduce a slider. So I'm again going to reparameterize the curve, and then I'll copy this. And so using these diagonals, we can find those midpoints along the length. And given that we're going to work with a surface, what I want to do is use the surface as a way to determine how essentially the normal to come either above or below. And so the way that we're going to do that is we're going to take that point and we're going to find the surface closest point. And we'll plug these points in. So let's see, we're going to need the surface. So I'm going to plug in the B-rep to the surface, drag this back over, and copy it 4 times. And then we'll take these points. Which is not unlike projecting these points to the surface so we can see. So here's one of our points along the line, and the closest point on that surface is essentially a projection to there. And the reason why I want to do this is that I next want to evaluate the surface. And what's handy about this, I'll drag this back over, is we're going to use the same surface again, our brep. And this component is useful because it gives us a normal to the surface. And rather than connecting point to point here, we're actually going to use UV point. But I'll copy this 4 times. And now we can connect UV point to UV point. We might be able to start hiding a couple things here. So now we can see our point along the diagonal, the closest point, and then what's nice now is that we have the point and the normal. So what I'd like to do is to create a line, this time the SDL, which is the start point, the direction, and the length. And so, let's see, we're going to need 4 of these. And so our point is going to be the start. I guess I could have added a slider first. So let's create a slider that's 5. Or let's see, I don't know. We'll see what the scale is. 3 is less than 20. We'll plug this into the length. And the normal is going to be the direction for this line. And so we can see just, I think, a line starting there. So if we increase the size, we can see where that is, and we can also determine whether or not this should go in one direction or the other. I'm not so worried about the curvature of this brep in relationship to these, because they could flip and change at any point. So I'm going to plug this into the length for all of them. We do want to flip 2 of them, so we just want them to be consistent. So along this diagonal and this diagonal, let's see if that's, so that's these top 2. Those are working. Now let's reverse the vector from these normals. Which should send these in the opposite direction. So along this left to right here, we can see those 2. So that seems okay. I'm going to increase, let's see, 3 is relatively small. I'm going to increase the maximum, maybe just double it to 40. Just so we can get something extreme, so we can get a sense for where these are. Okay. So that's working now. Let's hide a few of these things. I don't need to see those planes. I don't need to see those projected points. We don't even need to see the midpoints anymore. We've got these. Okay, so the next step with all of this is that I want to create a interpolate curve from the endpoint through the endpoint to the other endpoint. So from these elements, let's get the endpoints. times. There's a lot of copying 4 times in this tutorial because we're going to work our way around all of these. So let's start with this element. We've got those endpoints. Again, I just like to use a point container to be sure which one I'm getting. I want that top. So over here, we're going to go from this point to here and to this point. So let's create an interpolate curve. And we'll have our lines. We're going to go through this whole process of trying to find these points again. You can see if this works. So we've got our first point there. We're going to take our next point and add it just by holding down Shift. And then let's try and find our third point. Which is there. And hold down Shift again. Now we can see a curve that's moving from that point up and through and back. And it's a kind of extreme curve. It's not going, we're not going to use this curve for anything other than to get its tangency at that point at its peak. But let's repeat this 4 times. And actually, before I do that, I'm going to disconnect these. And let's see, we'll do the same thing. We're going to start, connect this. We're going to want the end again. And we'll find this point on the left. Our first one there. Connect it. Our second one, hold down Shift. And then we need to find this third point. Which is here. Hold down Shift, and then we connect that. So now we have our 2 upward curves. These are based on our slider that's here. So we can see the way that that varies. At this point, I'm going to rename the slider. I'll call this middle thickness. And seeing that it works, I'll drag it all the way over to the left again so that I can get my couple of parameters together here. So now we're going to work with the underside. So we know I use that maybe by hiding some of these. Some of this might go a little faster. Don't think I need that line anymore either. Where are these? Let's see, maybe I'll keep those points on. So let's do the same thing. We'll grab these elements. See if it's again the endpoint. These are going down. So those are both working. Hide those. And then I'll get another interpolate curve. And while I'm here, copy this a couple times. Okay, so we'll start with, look a little bit from above. I just want to go in a consistent way, but if we're not consistent with these, it's okay, because we can always reverse the direction. But I'll look for these. That'll be my first one. I know this is the second one. And then, nope. I can selectively disconnect these. I'll have that point back in. And now I'm looking for the third point over there. Which is here. Hold down Shift and plug that in. So I've got those. You can hide that line. And this just leaves us two more. That's our first one. Hold down Shift, we get our second one. And there's our third point. And so we've got that. So I can hide the line. I can hide these two lines. And those 4 points. So now we've got these two curves that we can control, both in terms of their width. So if I look at this from above, here's the width, and then if I look at it from the side, we can control how flat or how thick that is. All right, so with those, now what I'd like to do is to begin working on, we need a couple of edge lines that will allow us to begin to work with our tangency curve. And so for these, let's begin by evaluating a curve. It will drop down here to the bottom. And so we'll evaluate curve. The curve that we want to evaluate, I believe, are these 4 edge curves again. And we're going to do the same thing. We're going to have each one come across. So we're going to need 8 more of these following the same general approach. And so let's create a new slider. And we'll say, from the edge, let's say 0.02 is less than 0.33. And again, we can always adjust these later. We'll plug that into the parameter. We will re-parameterize the curve again before we copy them all. So 4. And then we're going to do another 4, which will be, again, the 1 minus. And so we can even grab that 1. Copy these. Just be sure to switch what you're subtracting. We've got those set, and how about we copy all 4? And then swap out the parameter. And we're using 0 to 1 along the length, which is why that's why we're re-parameterizing the curve. So it's not using a dimension, it's using 0 to 1. And this also makes it nice so that whatever our parameter is, we can then subtract that from 1 to get the corresponding other side. Let's call these edge limits. And so now we'll begin to look at these curves. So let's do the same thing. Let's pull these from above. The first, second, third, and fourth. And 1, 2, 3, and 4. So now we've got a whole series of points along the edge. It's always useful just to change your slider just to make sure that those things are working. And so now let's create a series of lines with endpoints. And so we'll start with this one. And now we're looking for the one in the right. Given that that's working, we're going to need 4 of these. So let's maybe do the next left to right. It's here. To here. Again, just being careful how you're doing start and end. I'm going to do the verticals, start there, and start and end. Okay, so we have these along those edges. Now we're going to have to find the midpoint of these. We'll do that again with evaluate curve. Again, reparameterize curve. Here, we'll set a panel at 0.5. Then we can copy this 4 times and plug in these 4 curves. So now that we've got those, again, it's just kind of working through these things, trying to understand how they're going and what they're doing. But now what we could begin to do is to connect through some of these to begin to make our tangency curves as a way to work with them. So let's take a look at well, we've got enough to work with them. I'm going to use the weave as a way of maybe controlling and being careful about the order that we plug these in. So let's do one and I can talk through how this works. We're going to have 3 points to make a tangency curve. So let's find that. Tangent curve. And this will be, the weave will come from the vertices and it will come from the tangents. So let's start with one of these elements. And what's going to happen is it's going to come, it doesn't matter where we start. I'm going to go from this point, tangent along here, up to this point, and then tangent to here. All right, we're going to be, again, making this kind of continuous curve. And the reason why we're going to use the tangent curves is that when they get to the end, they're tangent and they'll meet up perfectly with the next line or the next curve. So let's start up here. We're going to come like this. So let's find that first point. That's here. Let's plug that point into the first stream and the tangent into the stream 0 of the first weave and the tangent into the second weave here. We're going to need to make a panel, and for this we want this, right click on the panel, we're going to set it to be multi-line, and we're going to set this to be 0, enter, 1, enter, 2. Just gives us the order that these will go, or the pattern for the weave. So our first point is there. Our second point that we're going to look for is this one here. It's not those. So it's this point along that interpolate. And I think what we're actually going to have to do is add an evaluate curve over here, because what we want is to take that curve, again reparametrizing it, and finding its curve. Well, let's find that midpoint again. Using the panel. Plug that into the parameter. The reason why we're doing this is that one of the things that comes out of the evaluate curve is the tangent, and so we actually want to get this curve and that midpoint so that we can get the point and the tangent there. And so let's set this one up. We'll pull the point down to here. We'll pull the tangent down to here. For both of these weaves, we have to add one more input, which will be our other point, which is here. The points in the top, the tangents on the bottom. And now let's plug the vertices and the tangents. So, of course, these are the first and third tangent needs to be reversed. So we can reverse a vector. And so this is the first. And the same thing here. And this is really the benefit of using the weave. And now we can see when we look in 3 dimensions, or as we orbit around, this curve is starting its tangent with this line. It comes up, finds tangency along the interpolate curve, and then comes back down and meets there. And so then what we're going to do is move over here, up, down, and then connect it. So we get this kind of cloverleaf pattern with this kind of approach here of using the weaves and using the tangent curve. So let's continue through where we're going to go now, where we went up. Now we're going to go from this point, and we're going to go down over to this point. So same thing applies. We're going to need another weave. And at least knowing that these work, what I might do is plug this in and copy. We're going to need 8 of these. Because we're also going to need that tangent curve. those, and we actually know we can connect the vertices and the tangents. We have those. So now let's look and see what we have for our points. So this will be our first point for the second. I should have added the additional streams before copying those. And I'm just going to, we added that reverse vector. I'm going to just add it without the reverse. It's kind of 50-50 chance whether or not that reverse is needed, but I think given that we needed it on the previous one, we may not need it on this one. So now we want to find this point here. We know that's above. We can copy these evaluate curves and plug in the curve. Let's find, so this is that lower one. We know that the point is going to come into the top and the tangent is going to come into the bottom. And then we'll come back over, and then we want to find this point here. Which is here. This will be the point. And the tangent. Now let's see what the curve looks like. So the first one is correct. The second and third need to be reversed. So that's here. And then we'll reverse this one as well. This will come to the tangency, which is the middle here. So now we start to get a sense. As we started with our curve, it's coming up. It's connecting back here. The beauty of those tangency curves is that these two curves align. Now it comes over, comes down, comes back up, comes to here. So next thing that we're going to do is go from this point up and over to that point. There's a couple of points here, so we'll see what we have to work with. All right, so we're looking for this point first. It's not those. So it's here. This will be our first point. And tangency. It's going to come to the upper point. Which is here. And I'm just going to, so I don't get confused, I'm going to turn off those other points. Maybe I can leave the interpolate curve on for now, but I'll grab the point. And the tangency. And then we're looking for this point over here. Quickly find out that we need to reverse both of the first second. I'm using these relays just as an easy way to kind of plug in here to see where I'm looking for. Because I can pull out of the relay, I can plug back in there, and then I can just delete the relay when I'm done with that. So that seems to be working. So now we're 3/4 of the way done. We came around, we came up. So now we're going to come from this point to this point to this point, down. So let's look for this point. This point here, process of elimination again. We'll grab that point and the tangent. It's always the last one I click. Point and the tangent. We're almost right with those, except our first one needs to be reversed. We may already have another reverse somewhere over there, but this is easy enough. Delete that relay. And now we've got that. So as we look at this, we can see that continuous curve in the way that that's working. I now want to hide all of my points, but I think I'm going to hide those interpolate points. And we are going to have to add a couple of points, because the next step, now that we've got that curve working, what we're going to do is we're going to basically work our way through and build up the edges that we need for a patch surface. And so this is what we're actually going to do is, just like the Erwin Hauer, where we've got a break line at these points, we need to find that line, and then we're also going to have to find these edges as a way so that we can define a complete edge condition for the top and a complete edge condition for the bottom. I know it's a little tedious, but as we work through, you get a better understanding for all of these things, and you'll see the kind of flexibility that one of these individual objects has. So why don't we start, we're almost going to go back to all of our edges, because we've got to find a midpoint along this edge so that we can get a line here and a line here. So let's see where that is. Maybe now is also not a bad time to save. Might be tutorial 4. Okay, so now let's look at what we've got all the way back at the beginning. We have these edges. And I don't believe that we found the midpoint for those. No, because we were using a different dimension to find those locations. So maybe we just up to the top here, add an evaluate curve. We'll reparameterize. We'll create a panel. It's going to be 0.5 for our parameter. You can copy it 4 times. And now let's add these curves in. And so now we've got midpoints along each of those points. Maybe pull this down. And we'll start working. We'll see what we can use. I think we're not done with those. I think we're also going to need the endpoints of these lines. From these curves. So we'll do the same thing. We'll grab each of these. We may only need 2 of the 4 lines, but it was easy enough to do while we were there, and now we have those. So let's begin to work our way around. We're going to use weave again as a way to build up our the patch surface, but let's start with a couple of lines. So I'm going to start with this endpoint. Let's see. So it's this one, and it's the end. So I'm going to come from this endpoint to this midpoint. I'll make that a line with endpoints. So our start and our end. So now we can see our first line is here. Our next line is going to go from here to this middle point. So I'll make another line with endpoints. And that should start where the other one ended, which was here. And now we've got to find this point. So here's that point. And we have that. So we have our first line, our second line. What's going to happen then is we're going to use this curve to here. And now we have to find this line. Or we have to define that line with those points above. So why don't we start there and then end with this point here. We have that. Now we'll do another line. Which will start there, and it will end at this point over here. Which is the start of that one. We'll go there. So now as we track our lines through, starting at this point, over, down, this curve, to this line, to this line. Now we're going to work on this line here. We'll start there, and now we have to find this midpoint here. that, and now we have to work between these. Start there. Now we have to find that end, which I think is up here. To there. So let's trace these through. We start up here. 1, 2, curve is 3, 4, 5, 6, 7, back to here. We need to go across this way. It's always the last one I click. So we go from there, now we go to the outside. And now we have to go all the way back up to the corner along that edge. So the last one for here. Is here, start. And of course we could do these with a polyline, we could do it in other ways, but I just like being able to kind of find all these things, track them, and be able to work through that way. So now we'll close that with our last corner. Which is there. Okay, so now we've got all of our edges defined. Now what I want to do is I want to weave them together as a way to make a patch surface. So let's create a weave. We're going to have a series of, I think, 8 or 9 or 10 elements. We're going to have a panel. We'll start with 0. First we'll make this multi-line data. Start with 0. Say OK. We'll plug that into the pattern. I was working earlier kind of iteratively through this and kind of deleting these and going one by one, but I think we're pretty meticulous up here. So let's start. We'll add this to 0, then to here. Now we just need to pick a direction, so I'm going to look for this tangent curve. That's second to last one that I pick, so we'll pick that curve, plug it in here next. Brings us over to this side. This curve. That one. Working our way around the corner. Coming back into here. Now we want to find this curve. Plug that into 7. And then we have the 2 last curves to plug in here. 8. And then 9. So if we click on the weave, once we have all of once the panel pattern is set and all of these plugged in, we can just kind of trace this all the way around, make sure that it makes sense, warp it a little bit, see that all of those are connected. So now our next thing is we can, I don't know if it's necessary to join them, but we can join the curves that come out of the weave. So we can hide that weave, we have the join, and now let's create a patch surface. So for the patch, what we're going to do is to bring the curves into the curves. And we can see the start of half of our panel here. The other two things that I want to set, I'm going to use panels, and I want to set this for the spans, and I want to set it for the flexibility. So at least when I used this before, I had my spans set to 20, and then the flexibility set to 100. Granted, we haven't really been working to a scale, and so your surface may be slightly different than my surface. But what we're really looking to get is kind of close match along that line and a kind of clean surface with these. So we're already at an hour in this tutorial, which I know is too long. But if I just hide, let's see, if I hide the B-rep, I want to hide a few of those other points too, but let's just look at our middle width, right, how thick that element is at the middle, how deep it is. So if we look at an elevation, be able to change this. So the patch surface is a really powerful surfacing tool that basically just uses a kind of edge, and you can use other points within there to define curvature. But we can see that it's working in terms of the surface is not breaking at all. You should now be able to work through and do your other half. I can do that before I start the next tutorial. But what we're going to do is, with the next tutorial, is, well, it's a good time to save as well. What we're going to do with the next tutorial is to work through different types of variations given this approach, right? If we have one surface, we can extract the edges. If we have a more complex, larger surface, we can break that down with iso curves and begin to get a distribution of these panels and start to add more complexity to putting all of these together. Then I think ultimately where I'd like to get to is being able to vary along, say, a location or intensity points or other types of things, to vary these parameters that might be context sensitive. And so here, right, if we change this and we replicate these, all of them will share the same parameter, but these parameters may be determined by localized conditions on there. So we'll look at that in a future tutorial, but I'm happy to finally get around to continuing this tutorial and sharing this approach for these things. So let me know if you have any questions. I'm happy to help and build your second half, and then I will continue with a way of looking at how we can replicate these things. Thanks.